Now I wish to continue, and let's start session 2. Name practical implementations. We have 5 companies: QStar Technologies, Point Software and Systems, Iron Mountain, MagStor, and S2 Data. Let's start with Dave Thompson, SVP Sales and Marketing at QStar Technologies.
Thank you, Philippe. So we're going to be talking about multi-node archive gateways. QStar has been around. Can we go on to the first slide? Yeah, QStar's been around for decades now, and we've moved along quite nicely with just sort of single node, single server type applications. It's worked very well, supported a whole variety of different users doing that. However, we're starting to see significantly larger archive requirements, especially in the high-performance computing world. And in the past, we've worked with clusters, so Windows or Linux clustering, to give us high resilience, but it doesn't give you any additional performance. It doesn't give you any additional capacity scalability. So we had to sort of go back to the drawing board and come up with some different plans. So we've gone to slide 2. So again, HPC AI now, as we've just heard from many other people, is we're talking about hundreds of petabytes potentially. Right now, maybe 20s, 30s we're seeing quite regularly, particularly for the HPC world. But we're expecting that to grow significantly over the next decade. So what we're looking at is the ability to be able to park that data at the lowest cost. Again, David from Wasabi mentioned about having the raw data and the archive data basically being this area of parked content. So it's basically areas that are not being used, or data that's not being actively used at that moment. It collects everything, and then when it's being used, potentially sort of for project-based or for the whole information set to be reprocessed, it's available, but it's still just parked data. So what we're looking for is to be able to add large amounts of tape storage without adding large amounts of disk storage as cache. Typically, organizations understand that data needs to be sitting there on low-cost tape, and adding more disk cache increases the cost significantly. To get to that high performance, we're looking at using many tape drives. So the way we do that is either through multi-drive, where we're actually amalgamating many drives together to be able to actually use a pool of tape drives, or another approach is RAID, which is the array of independent tape media, or tape drives in this case, so that we can actually get the performance of potentially writes and, of course, reads significantly improved. Higher reliability is obviously critical, so we're protecting that through either mirroring or replication to either a second system, or, of course, to something completely different, like it's a cloud system. So it gives you the flexibility. I have added a little connection on the bottom here, a hyperlink to a presentation that CERN did. CERN is not a QStar customer, but I thought a lot of what they were talking about was very, very relevant. So I would recommend somebody to review that. They are talking specifically about the way that they are moving data as they are taking it from the machines that are actually capturing all the information directly to tape. They are so tape-centric that they've actually created their own applications to be able to do that. We go on to slide 3. So why multi-node systems? Well, we're getting to the situation where HPC and AI have to use those fastest network systems available to try to eliminate bottlenecks. 100 gigabit plus networks are obviously very common. So, for your average organization, that is still sort of a bit of a push. Current tape drives are very fast. With native mode, we can do 25 LTO9 tape drives to support 100 gigabit networks. So that's a significant push for a single server node to be able to work with 25 drives. Obviously, it'd be less if we're able to claim compression. So a multi-node which offers us 2 to 64 node systems with global namespace, library sharing, so that any one of those new nodes can access any tape drive within that environment using all of the protocols available. We've mentioned S3. We still believe that there's a significant advantage with SMB and NFS in some of these worlds. Perhaps at the lower entry level, S3, I completely agree, is probably the where most people will go. And of course, trying to support those largest tape drives from all vendors with those very, very large numbers of tape drives. Thank you.
Good, thank you, Dave. Second speaker is Catherine Kersten, Marketing Manager at Point Software and Systems, presenting object storage tiering with active archiving for AI and data-intensive workloads.
Okay, thank you very much, Philippe. We can go to the first slide, please. Well, let me start with the special storage requirements of data-intensive workloads, and especially the storage requirements of AI modeling and AI workloads that are changing the whole requirements of storage infrastructure. These are challenges to traditional storage, to data privacy and data security, but of course also challenges regarding compliance and archiving, and challenges regarding the energy consumption. So on the next slide, we'll see that S3 object storage dominates these data-intensive workloads. The top large language models are trained on object storage, so object storage and AI really go perfectly together. That's because object storage basically provides a lot of advantages, especially for the needs of AI. First, it's highly scalable in terms of capacity and performance. It can handle millions of concurrent requests. It integrates directly with AI frameworks. And last, it provides rich metadata support. So it allows indexing and faster retrieval of data, or by which it really enhances AI workflows. But on the other hand, of course, the exponential data growth leads to increasing storage and energy costs. So organizations must find a strategy to minimize expenses while at the same time keeping data sets available for the AI model training. And organizations must also take into account that these sensitive data sets need strong protection to meet compliance and regulatory requirements. So this is where an active archive architecture comes in, offering a secondary storage class and using cost-effective and sustainable storage media like tape, for example. Next slide, please. Oh, we already have the last, sorry. Not all data generated by AI systems remains in constant use, so certain data sets become inactive or cold. But even if they are not actively used, they still hold value and must be stored for the long term, of course. So if you integrate an additional storage class for this dormant data, the high-performance productive storage class can be freed from inactive data, and certain data sets can be moved to the secondary storage class. For example, data that is no longer used in the AI model, but may be useful in future projects, data that must be archived for legal or regulatory reasons, and testing data. If you use object storage for productive data, you should also use object storage throughout all storage tiers, so also in the secondary storage class, for various reasons. Integration should be homogeneous through the standardized S3 API throughout the whole storage infrastructure. And second, many hard disk-based object storage systems have their own integrated tiering and lifecycle features for automatic tiering to a secondary storage class, like, for example, tape-based object storage, so you can rely on these integrated features. The secondary storage class should, of course, use storage media that is both energy efficient and capacity oriented, like tape. There are various reasons for combining tape and object storage. They really go well together. S3 and tape both work sequentially. The S3 protocol can handle tape latency easily. And last, when it comes to data security, object storage is designed for immutability, and tape media can provide the additional warm protection, air gapping to fulfill compliance and regulatory requirements. So if you use S3 object storage on tape as a secondary storage class within an active archive architecture for AI workloads, you will have many advantages like cost efficiency, scalability, energy efficiency, of course, sustainability, and also seamless integration. So thank you. We'll hand it back to Philippe.
Thank you, Catherine. Now, Iron Mountain with Paul Lupino, Director Data Management, presenting a talk about leveraging archival data for AI training.
Thanks very much. I don't know if I could have had a better segue from the previous speaker into what we're talking about today for archival data. I think we may have covered the concept. People get what the archival data is, and it's sitting on a variety of different formats, and people still need to be able to get at it, right? And so I think what might be more useful for my few minutes here is just to talk about what we're seeing customers say they're doing to get at, with some of this data. So I think that the main idea here is that having access to archival data, especially specific to your organization, can be useful when you're trying to build or leverage, those data sets for your own artificial intelligence, purposes. So we see, for example, life sciences companies going back and looking for data to build new vaccines. Right? We have genomics companies that are looking to get data off of lots of tape in order to bring those large data sets into the cloud so that they can sell it to other people to do research on, right? So I think that we probably covered what the concept of archival data is, so we can move to the next slide. So I think the benefits are, in addition to what the previous speakers have already said, it's that sometimes it's getting access to your own data that's useful, right? In order to leverage it to build on top of your current products or services. If you're looking, for example, we had a recent customer looking to go back in their backup data sets and sort of release that data in order to look at their own customer interactions and see, what can we learn from that in order to bring new products to market, right? So I think the specific benefit of that archival data for your own use is useful when, like I said, developing future ways to monetize. I think the next slide kind of talks about a few of the pitfalls. So I think one of the big challenges is how do you keep access to stuff that, it's old, it's new today, it'll be old tomorrow. So how do you get access to that data if you have data that's on an LTO5 tape and you don't have an LTO5 drive anymore? That's going to be a problem, right? So I think as we're watching people come back and say, hey, we want to be able to find this data. Another example I had recently was a video game manufacturer, and they said, we got all this data over the last 10 years on a variety of formats, including tape. Can you help us get access to it? Great. Now that I've done that, how do I find it again in the future, right? Because it's sitting on old formats. And so that's kind of where their active archive journey is going. So I think the main idea here is that the keeping access to all data on various formats is tough, and it can be difficult to do. So it's something you have to think about when you're storing this data. How do you future-proof it so you can use it for additional AI training in the future? I think that's it for me.
Thank you, Paul. And we continue now with Pete Paisley, Business Development at MagStor, about data migration strategies for tape archives. Pete,
Sorry,
are you connected?
I didn't.
You're on mute, I think. Okay,
I
good.
am unmuted now, I believe. Thank you, Philippe. Sorry about that. Rich, next slide, please. Well, this is a bit redundant based on some of the prior presentations, but let's start with the big picture. When we talk to customers today about their storage needs, issues around data migration are common precursors to crafting overall solutions. And the saying that goes around today is there's new money in old data. And customers often need help making that old data accessible via migration efforts. And this is how we scale for the petabyte era. Most of our customers are dealing with data storage requirements of many, many petabytes today. And this is driven by AI's massive data sets. Because people are repatriating historical data to train their large language models, et cetera. As mentioned previously today, this morning, data security is a key issue. That's why tape is often a strong consideration, and we are brought to the table. And tape does a great job of balancing online or nearline access versus economical retention times to improve AI outcomes. And a key factor here, and I think this probably addresses the question earlier, in my mind at least, my humble opinion. Why will storage costs increase this year and next year? Well, energy costs will probably be a key driver. It's been a few years, but Gartner found that the average annual storage cost per raw terabyte of capacity was $738, and that was in 2019. So now that's based on disk. So everybody wants to create a storage solution that has the lowest possible energy demands while meeting their other needs. Next slide, please, Rich. So many of us are familiar with the total cost of ownership data from the LTO consortium. TCO for tape is a fraction of cloud and disk. So that's why often we are seeing people migrate data to tape wherever possible. And security for tape archives is quite clearly superior, as it's immune to cyber attacks, it's air gap storage, unauthorized access is more difficult, etc. So migrating AI data sets to tape becomes the operational challenge. How do you repatriate old backups or captive backup formats and unstructured data or email data? Next slide, Rich. Thank you. So some common areas around data migration include how do we migrate legacy tape archives to disk or current format tape? And the decision parameters are often, do we do it in-house or do we outsource it? Some of the primary factors here are there's a lot of labor involved. There's auditability and compliance concerns. And there's the hardware costs to perform these migrations in-house. Partners like us can provide these services on an outsourced basis, of course. How do you take legacy backup platforms to disk or tape? Same issues. Merger and acquisition driven data migration. Similar issues, but with different parameters. How much of this data do we need now? What kind of labor? Do we do it in-house or do we outsource it? And many people are talking to us about repatriating cloud data to tape. And again, same factors involved: labor, compliance, hardware costs. And email archive migrations have their own set of parameters as well. Another thing that comes up is as people migrate to tape, they need a good plan for offsite tape vault. Mountain, who went prior, is well known for this because this cost equation for secure low-cost storage. And I want to finish by pointing out that there's some options that aren't well known in the industry for subscription-based services for very low frequency access-based data. So you can have the benefits of tape without owning the hardware, and you can take some of your tape archives and sign up for a subscription service where the data recovery will be done for you. Now, the recovery time frame is within a matter of days or even a week, but for certain types of data, this can be perfectly acceptable. And the cost of maintaining access to this data can then become extremely, extremely low through subscription-based services to some of your data that fits that profile. Thank you for your time today.
Yeah, thank you, Pete. And we conclude this session 2 with Curtis Preston, technical evangelist at S2 Data, presenting Making Active Archive Searchable.
Hello, everyone. Thanks for joining us today. Just want to talk about it's really great to have an active archive. One of the challenges that I see, and it's, again, it's probably based on where I've spent my time lately, is this idea that we have a significant amount of data that is legally discoverable that isn't necessarily, it's accessible because you have it in an active archive and you can get access to it. The question is, do you have the ability to search that data if you get, for example, an electronic discovery or e-discovery request, which is, especially for those of us that live in the U.S., a very litigious society, or if, of course, you get some sort of regulatory requirement to do an open records request or something like that. So the big thing here is, if we could search these static archives, we could turn the archive into more of a knowledge base, and also when we talk about the legal teams, allow them to easily access that historical data, maintain that compliance, and also possibly organize that content by matter, meaning by legal matter, right? So by case. Next slide, please. If you have search, it really unlocks the value of all of that data in the active archive. For example, if you're able to do full text search, and this is something that we've talked about on and off throughout the years. If you're able to do that, if you can say, give me all of the documents that have this phrase, give me all of the emails that are from this person, and then what you're able to do then is if you're able to, use filtering for different authors, different topics, etc. Obviously, we talked about earlier, one of the speakers talked about tagging. This is a great way that as you're searching and as you're identifying data, a particular document or email, if you're able to then tag that for later reference, obviously you have to keep security front of mind as you're doing all of this. This is something that S2 Data does today with a tool called Lear AI, which is why when I heard that this was about AI, I thought that would be a perfect thing to talk about. And what we do primarily is we help people access legacy data in a lot of formats, mainly for the purposes of e-discovery and things like that. Next slide, please. AI really compounds the value if you've done the process. And by the way, this is no small feat, and earlier speakers have spoken of this as well. This is no small feat of basically reading and indexing all of the content that is there. The AI really compounds that value in that you're able to do things like categorizing all of the historical communications. Show me all of the emails or documents from this particular custodian, which is a term in the legal world for just the people, the person who's created that content, and then also pattern recognition. Look for show me emails or documents where there seems to be some animosity, right? Where there's contention, things like that. And then also search. This is where, for those of you that have done anything with LLMs, the importance of context and things. AI can really help there. Analytics, and then also, obviously, natural language processing, being able to have conversations with a model about all of this content that you're storing in the archive just significantly increases the value of that especially for legal and e-discovery purposes. With that, I'll hand it back.
Good. Thank you, Curtis. Now again, I have some questions for our speakers, and one of these is related to, I think, Iron Mountain And the question is, how does Iron Mountain think about data refreshes and the associated cost of refreshing?
So I can try and take it. Depends a little bit about what is meant by the question, but if we're saying, for example, I need to refresh my archive data to use for the future, and I don't want to keep spending money to free up the access to it, if that's kind of the nature of the question, then we usually suggest to people that they narrow the scope of what they're trying to recover and try to recover it once. So for example, if you're getting data from backup software, do you have to refresh? Do you have to get all the data off every tape, for example, or could you just get the data you needed off the yearly backups, as an example? And that would really narrow down the scope and the cost. So I think there's the ways to approach it that would make the refresh of that data less expensive. If that wasn't the question you had, then let me know.
Okay, good. And another one is related a bit to what Curtis mentioned during his talk, and I wish to extend this a bit. How do you explain why content indexing, let's say indexing of the content without any sense, meaning, etc., interpretation, how do you explain why content indexing didn't really take off before our current wave of AI?
That's a great question. I think there's a couple of reasons. First off, content indexing is just hard, right? It's just a very difficult process to have. And although we have the capabilities to do it and other companies have the capabilities to do it, there are often not driving factors that push people to do to go through the kind of costs and effort that they need to do. Very similar to other things when we talked about data refreshes, right? It's a very costly process to do. And so a lot of people just don't do it. So I would say just the general cost of that. Also, I think data indexing has gotten better over the years. And so it's sort of happening simultaneously with AI, but then also now with AI, not only do you have this index, but you have the ability to interact with the index in in this natural language way and to just ask questions that in a way that's very different than a, select star from table where blah, 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 right? It just increases I think the usability of it.
Good, thank you for this.